Welcome in, guys. Welcome in. Welcome in. We're gonna wait for a little bit. I just got off the other live, and here we're gonna do some demonstration of the Taylor series and all that stuff. So I'm gonna go with some basic Taylor series with you guys. All right, we'll wait for you guys to come in. We're gonna erase the board, and we're gonna do some math operations. So there's a way to erase this. Welcome my YouTube fans. So what I'm going to talk about, guys, Taylor series expansion. I'm talking about the Taylor series. That's right quick. So what we have here, we have the Taylor series with respect to x, and we're gonna allow we're gonna allow this to be our function of x plus x factorial x squared 2 factorial x cubed 3 factorial, so on until we get to f k plus 1 k plus 1 factorial. And so this is a very important theorem. This helps us approximate functions. Other functions. Like, you have a quadratic, you have all these functions eventually. So I got T1 and T2. Eventually it'll fit the curve. Just about. T3. So the closer you get to that curve, you have the exact function, right? So we say f of some numbers, f of some number 0 is equal to f prime of 0. In some cases, on your f of 1, okay, make the adjustment equals f prime of 1. Case number 2. Okay? And that's what we're looking at. I'm gonna well, come on in, guys. Come on in. We're talking about the Taylor series. How are you? How you doing? We're doing Taylor series here. Hello, how you guys doing? Let's hit that like function, that like button, please. The like button. So we're just doing a little mini course on Taylor's theorem. Hope you guys can see it okay. I hope you guys had a great holiday. I was going to be on it for a few minutes, so this is a demonstration. This is what I do. And don't forget, you guys can meet me over at the top. I'll go by the math tutor over there as well. All right, y'all keep coming in. I'm keep giving demonstrations of this. Okay, so you guys behave. We'll be here for a little bit, not too long. All right. So those who took Calc 2, guys, that's called a Taylor series expansion. So again, we're going. Let's little basics. So basically, the theorem goes like this for any function. So the theorem, let's put the theorem right here. Try to write this neat. And basically, we're going to say t of x is equal to f of k plus 1, k plus 1 factorial. Okay? This is used to approximate other functions. Very beautiful, very succinct. All right. And what do? You add term by term. You guys add term by term. Anybody have any questions? Come on in. Anybody have any questions? Let's go. Feel free to come in, guys. Come in. Your comments, come on in. All right, so we'll do a few examples utilizing the Taylor series. So let me go ahead and erase this right here. So let's do two. So we'll do a series expansion on our roots. So f of x equals the square root of x, right? So we're going to do a series expansion of that. So we got f of x equals root x. That's our first one. Then we'll take the derivative. 1/2 x negative 1/2. You do the second derivative. 1/4. And negative 1 to that, it'll be negative. So you're going to minus that, so negative 3/2. So we'll keep it like that. So we do a function root over x plus 1/2 times y times 1 x negative to the half power plus 2 times 1, so it'll be 4 times. So it'll be 4 times 2, 8. So it'll be 1/8 negative 3 over 2, and so forth. And if I put in the 1 here, that'll be 1 plus 4, 1, 4, approximately. And this is not the whole story. This just, because we can't allow this to be 0, right? If we allow this to be 0, what happened, this would be undefined, so we allow this to be 1. So remember the root 1, so it'll be x minus 1. Don't forget about that part. X minus 1. So keep that in mind, you get that. So that's pretty cool. I'll keep it up there. That's pretty cool. So Taylor's is very, very powerful theorem. Very powerful. Welcome in, everybody. Welcome in. Yeah, welcome in. We got some smart people in here. All right. We'll try to keep this about a half an hour. Let's do a cool one, guys. Let's do a cool series expansion on the cosine. Okay, so that's our function. So the derivative of that equals negative sine. Second derivative equals, if I do sine negative cosine, you with me so far? If I put 0, that's going to vanish. I put 0, that's going to be a 1. So that's a negative, and it's a negative, negative, it would be a sine. And it'll be a cosine. So if I put a 0, that'd be 1 plus. If I put a 0, that'll be 1 plus. That's gone. And that'll be a negative x squared. Over 2 factorial, right? And that'll be a 0 here, that's right. A 0 here, that's gone. And I put a 0 here plus, so squared to the 4th, right? So we got a negative, positive, negative, right? Negative, positive, negative. So this would be our cosine even powers, and this would be our sine. So that'll be x to the cube. Well, x to the cube. So we're gonna do x to the 6. Now we want odd, so x cubed, x to the 5th. So that's same idea. So that's pretty cool. So that's about right. So you start at 0, right? We gotta start at 0. That'll give us our desired number. You're doing it around the origin. Come on in, guys. Come on in. Where's everybody at? Come on in. So yeah, guys, this will be it for our discussion, and we'll see y'all later.